Hello friends, this video on Haloalkanes and Haloarenes part 23 is brought to you by examfear.com. No more fear from exam. The next kind of reaction is E2 reaction. So E2 reaction is the one which needs a strong base. Please note here base has to be strong. Strong base plays a critical role and the solution has to be aprotic. Why aprotic? Because if the solution is protic, it will nullify the effect of base. Right? Protic solve, because if let's suppose I'll take this example where I explain you that the solution is protic, it will have H plus and it will react with base. And it will be, if you see, this is acid, this is base, it will be acid base reaction. So we don't want that to happen, we want the base to be strong. So we'll keep aprotic solvent. So if you see, E2 stands for bimolecular elimination. Please note, E2 means bimolecular elimination. That means the rate of reaction depends not only on the substrate but also on the reagent. Here that is strong base. So the rate of reaction depends on the strong base and also on the substrate. Correct? So this is one step. Similar to SN2, it is one step. So there's in SN2 we have seen there's a strong nucleophile that attacks from the back and kicks one halogen out. In this case, there will be a strong base that will attack the hydrogen. Please note, the base always attacks hydrogen and the nucleophile always attack carbon in most of the cases. 99% of the case you will see that base attacks hydrogen, because base is the one which attacks hydrogen and nucleophile is the one right here. Nucleophile attacks any other element, in mostly carbon. In mostly carbon, we'll see, since we're talking about organic chemistry, you'll see mostly it attacks carbon from the back. And that's why we have seen that there is something called inversion in case of nucleophile attack, strong nucleophile attack, there is SN2 reaction. So here also there will be instead of strong nucleophile, I'm talking about strong base here. Please note that's the critical difference between E2 and SN2. In SN2 we talk about strong nucleophile which attacks carbon. Here we talk about strong base which attacks hydrogen. Correct? So there's a strong base which attacks hydrogen and then that breaks carbon hydrogen bond and then it gets a charge and then negative charge. With that the carbon halogen bond is also broken. So this is a scenario wherein we have a chair and in this chair there was a guy and there is a girl. So here the guy leaves first. The guy leaves first because there is a strong base, there's a huge amount of money that is coming in and the guy was attracted towards huge money, right? The guy is attracted towards huge money and then the girl is lonely and she also leaves. This is a typical scenario where this happens, where the guy is first attracted by the huge money, so the guy leaves first and the girl is lonely and the girl leaves second. There's a girl with a long hair, right? This is a girl. I have not drawn pretty good, but this is how it should be. So let's see this detail now. So here E2 is again, as I told, one step process similar to SN2, right? It typically undergoes a primary and secondary halides only. Why? Because you need have place for attack. And this, as I told, E2, that means the rate of the reaction is influenced both by substrate, that is alkyl halide in this case, and the base, right? That is the reagent here, strong base. So as I told, E2 use strong base because this is the one that attacks. And also as I told, E2 needs aprotic solvent. Why? Because if the solvent is protic, then it will make this base weak actually. Right? Base will be weak because we'll not use the term nucleophile here, it will be a base. It's all base here. So if you see here the reaction is, this is my substrate, right? Now on this, the first thing that happened is this is a strong base and this will attack this hydrogen. Correct? The strong base will attack this hydrogen. The very strong base. Strong base is mandatory in E2. See, even the base, even if it is weak, it's okay. In the last section we have seen the base was not weak, the base was good. But even if the weak base is there, it's okay. But in this, the strong base is mandatory. So in this case, the strong base attacks this hydrogen. That is the first step. Right? And then the base attacks this hydrogen and the same time this will attack this hydrogen, take this hydrogen out, slightly negative charge will develop and then this carbon will kick out a bromine. It is in the one step transition, right? So please note the difference. In the earlier case, in the SN2, the nucleophile used to attack a carbon, and from the same carbon one leaving group used to leave, right? That was my SN2 reaction. This is little different. So here I have a scenario something like this. So here my base attacks this hydrogen, right? See, base attacks this hydrogen, and with this, the base attacks this hydrogen, slightly negative charge is developed, and it will push this leaving group leaves. If you see here, the base is attacking carbon 1 and the leaving group is leaving generally carbon 2. Generally, most of the case. There can be scenarios where the base attacks carbon, the same carbon, the leaving group leaves. We'll talk about those kind of elimination, alpha, beta and gamma elimination, but most of the case it is this scenario. We'll talk about that. But just understand that there can be a scenario where you have a carbon, in this case, the first thing is it is base, right? It is base which attacks hydrogen, and then the reaction happens. The base attacks hydrogen, and then this carbon gets slightly negative charge, and then with this bromine is left, because this is the bromine, this becomes a little unstable, right? So this bromine leaves this compound and the compound becomes stable with the double bond. Now let's compare E1 and E2. So we have seen that in E2 strong base is must, but even the base strength is unimportant. Even if you have weak base, strong base, doesn't matter, but it has to be base. Base has to be there because there is a step called deprotonation, right? The second step, but that requires the base. So even the weak base will do in that case. Both E1 and E2 needs a good leaving group. That is necessary for even SN1, SN2, E1, E2. For all this reaction, the leaving group has to be good. E2 needs aprotic solvent, but E1 needs protic solvent. We have seen, because E2, if you see, the base has to be very strong. If the base has to be very strong, you can't have a protic solvent, right? If you have a protic solvent, it will make the base weaker. Steric hindrance favors E1. Why? Because steric hindrance, or you can see that, if you have 3-degree carbocation, 3 degree of third degree carbon, because in E1 you need to form carbocation. We have seen that in E1 and SN1 you need to form carbocation. So this guy is favored if you have 3-degree carbon with a carbocation that is more stable. So that way 3-degree carbon is favoring E1 reaction, and primary and secondary carbon favors E2 reaction. Now we'll talk about alpha, beta and gamma elimination. They are also part of E1 and E2 reaction, but see, there are so many elimination reactions. The first category we differentiated was elimination based on whether the rate of reaction depends on substrate or rate of reaction depends on substrate and reagent. So that was E1 and E2 reaction. E1 reaction, the rate of reaction depends only on the substrate. In E2 reaction, the rate of reaction depends on substrate and on the reagent, that is a strong base. Now we are again putting the elimination reaction into 3 different buckets, namely alpha, beta and gamma elimination, depending on which carbon the halogen and the hydrogen is getting removed. So the first one is alpha elimination. In alpha elimination, both the atoms are removed from the same carbon. For example, I'll take you through this example. I have my C, there's a hydrogen here, there's a chlorine, this is a compound, right? CCl3H. Now in this, if you see, all these chlorines are electronegative. They'll hog electrons. Each of these will have slightly negative charge. So these guy hydrogen will get slightly positive, right? Now, since I'm talking about elimination, now I'll have a base. So if this base reacts, attack this hydrogen, I'm talking about now which reaction? E2 reaction, right? E2 reaction, because the base is a strong base now. It's attacking the hydrogen. It attacks the hydrogen. And then what happens is this chlorine, any of the chlorine comes out. Why? Because it attacks the hydrogen is gone, it gets slightly negative charge because it is OH minus, slightly negative charge, and with that the chlorine comes out, and what you get is this is carbon with 2 chlorine and a lone pair. This is called dichlorocarbene. So if you see in this reaction, both the chlorine and hydrogen were removed from the same carbon. So they are called alpha elimination, very rare. The next is beta elimination, most common. For example, in this case, the two atoms are removed from the adjacent carbon. One is hydrogen and the other is halides. Both are removed from the adjacent carbon. I'll take you through one example. Let's suppose I have this guy. So this is my compound. So in this, I'll use again a base. I'll use NaOH3. This is nothing but my CH3O minus and Na plus. Right? So this is my base. Correct? Please note, I'm not using CH3OH here. I'm using CH3ONA. This is I'm not using. I'm using this. Why? Because CH3ONA is nothing but CH3O minus and Na plus. This is the base, good base. This is a very weak base actually. This is a good base. Right? So we'll talk about more of these strong and weak base later. So with this, if you react, what you get is, I'll just write the product, this and this. This is my major product and this is my minor product. And this will be based on a rule. We'll talk about the same numerical later when we talk about the rule, why this is major and why this is minor, right? So there is a rule for that. We'll talk about that. The next is gamma elimination. In this case, two atoms are removed from the corner atoms and forms a ring. For example, I have this guy. Let's see, this is the compound. Yeah, this is my compound. And let us add the chlorine here. So in this case, again, I will use NaOHCl3, right? Because I'm going for elimination. It has to be a strong base. And let me put a medium also. If you want, you can put a DMF medium, or you can put the protic medium. Let's put a protic solvent. So with this, what you get is something like this. I'll not take you through the reaction mechanism of these. I'm just telling you this is how it will happen. This is H5. So here if you see, it is getting removed from the end carbons, right? So this guy and this carbon. This is called gamma elimination because they are removed from the end of the, they are removed from the corner carbon, this carbon and this carbon. And this kind of reaction is called gamma elimination. So we have alpha elimination, beta elimination, gamma elimination. These are all rare. The most common is the beta elimination, where the atoms are removed from two adjacent carbons. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.